You know all those things you use every single day? Your phone, your car, even the can of soda on your desk. Ever wonder how they come off the assembly line looking so perfect? Well, the secret, more and more, is giving machines the power of sight. Today, we're going to pull back the curtain on how AI and machine vision are totally changing the game for quality control, making sure that everything we build is built right.
So, here's our roadmap. We'll start with why even the tiniest flaw can have a massive price tag. Then we'll get into the nitty-gritty of how you actually teach a machine to see. We're going to open up its toolkit and look at 4 key methods it uses. After that, we'll compare the old, rigid way of doing things to the new, flexible world of AI. We'll see how a system's brain connects to the factory's muscles. And finally, we'll wrap up by asking a pretty big question. What does perfect even mean anymore? All right, so let's dive right in. Before we can really appreciate the solution, we gotta understand the problem. And it's a big one. Why is catching every single little mistake in a product such a massive, high-stakes game for manufacturers? Get this, there was a bottling line, just one, that was losing $40,000 a month. And here's the crazy part. It wasn't because it was making bad bottles, it was because it was throwing away perfectly good ones. The inspection system was just a tiny fraction of a second too slow. That's the kind of razor-thin margin we're talking about, and that's the kind of cost that makes you search for a much, much better way. For the longest time, quality control was all about human eyes on the line. But let's be real, people get tired. We get distracted, we make mistakes. It's just human nature. Automated systems, though, they are absolute machines. They're lightning fast, incredibly consistent, and they never ever need a coffee break. For modern factories, moving to automation isn't just a nice to have, it's a matter of survival. So, the solution is to give a machine the power of sight. And that's where this amazing field called computer vision comes in. It's all about training computers to see, interpret, and understand the visual world, just like we do, but way, way faster. But, it's not quite that simple. You can't just bolt a camera to a machine and call it a day. Teaching an AI to spot flaws is a lot like teaching a kid to recognize different animals. You have to show it tons and tons of pictures. Pictures of perfect products, and pictures of every possible thing that could go wrong. Building that giant, high-quality photo album, that data set, is actually one of the biggest challenges to getting these systems up and running. Okay, so let's say you've got the data and the system is trained. What's it actually doing when it looks at a product? Well, let's pop the hood and check out the 4 core tools in its toolkit. First up, we have feature extraction. This is all about learning to see what's important. Instead of getting bogged down by millions of pixels, the system learns to pick out the key characteristics, the sharp corner of a microchip, the specific weave of a fabric, the perfect circle of a drilled hole. It basically filters out all the noise and focuses only on the essential bits. Now, once you've found those features, you have to measure them with ridiculous precision. That's where location and dimension extraction comes in. And when I say precision, I mean it. We're talking about accuracy down to 1/50th of a single pixel. It's like having a digital ruler that's so precise it's almost impossible to even imagine. The third tool is a classic, but it's incredibly effective: image comparison. Usually, this is done with something called a golden template. The concept is beautifully simple. You take a picture of a flawless product. That's your golden template. Then you just compare every single product coming off the line to that perfect image. Any difference, even a microscopic scratch or a tiny smudge, just pops right out. And how it works is actually kind of brilliant. First, the system perfectly lines up the new image over the golden template. Then, and this is the magic trick, it digitally subtracts the perfect image from the new one. If the new product is also perfect, what are you left with? Nothing, a blank image. But any flaw, any little scratch or spot can't be subtracted away. It gets left behind clear as day. All the system has to do is look for anything that isn't blank. So simple, so smart. And finally, we have the brainiac of the toolkit, image classification. This is where modern AI truly flexes its muscles. It uses really powerful algorithms. You might hear them called convolutional neural networks, or CNNs, which are kind of modeled after our own brains, to not just see a flaw, but to understand what kind of flaw it is. Is that a crack, a bubble in the plastic, or just a bit of dust? This tool can actually classify the defect, which gives engineers way more information to work with. So, all these tools together represents a huge leap forward. Let's really unpack the massive difference between the old way of doing machine vision and the new AI-driven approach. This table really lays it all out. In the old days, an engineer had to sit down and literally write the rules. Like, if you see a dark spot that is bigger than 5 pixels wide, it's a defect. That's easy to understand, but it's super rigid. What happens if the factory lighting changes a little bit? The whole system breaks. Deep learning AI is the opposite. You don't give it rules. You give it data, thousands of examples, and it learns the rules for itself. That makes it incredibly flexible and powerful, but it comes with a trade-off. It needs a ton of data, and sometimes figuring out why it made a certain decision can be a bit of a black box.
Okay, so the AI system spots a defect. Great, but that's only half the job, right? Seeing a problem is useless if you can't do something about it, and do it instantly. This is all about connecting sight to action. And this is where speed is everything. Remember that bottling plant? A delay of 200 milliseconds, literally less time than it takes you to blink, was costing them thousands. On a production line that's cranking out hundreds of items a minute, the vision system has to talk to the factory's control systems, the PLCs, in real time to, say, kick a faulty product off the line. There is zero room for lag. That need for speed creates a really important choice. Where does the AI do its thinking? Do you process the images right there on the factory floor? That's called edge AI. Or do you send the data off to a massive server in the cloud? As you can see, there are trade-offs. The edge is way faster and better for privacy, but the cloud can handle much more complicated AI models. It's a constant balancing act. But man, when you get that integration right, the payoff is huge. Well-integrated AI vision systems have been shown to cut down on those costly false rejects, throwing away good products, by an incredible 90%. That's a direct line from smart tech to less waste and a healthier bottom line. And it's not just about better performance. It's also about speed of setup. Because these new systems are built to speak the same language as the other factory equipment, you can get a new inspection station up and running up to 75% faster. We're talking about deploying in days instead of what used to take weeks or even months. So let's zoom out for the big finish. What does all of this really mean for the future of manufacturing? The goal here is so much bigger than just playing defense and catching mistakes. This quote really hits the nail on the head. The ultimate goal isn't just to build a better mousetrap to catch defects. It's to use the data from the vision system to create a smart feedback loop. The system can tell the other machines, hey, I'm starting to see this tiny flaw appear, so the machine can adjust itself in real time to stop making the flaw in the first place. It's a shift from being reactive to being proactive. It's about aiming for perfection from the start. And that leaves us with a pretty wild thought to chew on. As our machines get closer and closer to being able to see and fix every single possible imperfection, how is that going to change our very idea of what it means for something to be perfectly made? That's the future we're building right now, one pixel at a time.